Hey everybody, this is Larry. This is me doing an extra algo problem because well, we just had an easy problem for the daily problem. So let's take a look. Did I click on it? I think I clicked on it, right? Oh, there you go. And today's problem is and it's February 26th, 2024. Almost at 2029. I don't know, these years, who knows? And why is things not loading? Is it Leetcode? Is it me? Who knows? Hope everyone's doing okay. It's been a little bit chaos in my life a little bit the last couple of days. Just I don't know why. But I did do okay on the contest, so that's fine. Alright, it's finally loaded. Today's problem is 1746, maximum subarray sum after one operation. So you're given an integer nums, you must perform exactly one, so you have to do ones, where you place one element I with the I square I. Okay. Return the maximum possible subarray sum after exactly one operation. Okay, that's interesting. Okay. I mean, that's actually a cute problem. We'll see. I actually don't know this off the head, but let's go play around with the observation, right? The first thing to note is that n is 10 to the fifth, so you cannot do n square. And here, if you are able to do n square, my thought might be that you do Cadane's algorithm, and just try every possible number, and then use Cadane's algorithm. I'll type it up. And Cadane's algorithm is just like a name for things, but it's just like it's dynamic programming in a way, linear kind of way. So I think the idea here then, right, from that is just run it in parallel. And what I mean by that is that because you have exactly one operation, so at every given time, and if you kind of think about it as DP, which Cadane's algorithm is, even though most people do the space optimization, directly because it's just easy to remember, I guess. Because you can lift that one operation to a new dimension. So from that, it's definitely possible to Cadane's algorithm with one operation, and you just keep keeping more things. So definitely, if you're looking at this and you're watching this, and you you haven't studied Cadane's algorithm yet, Cadane's algorithm solves maximum subarray sum. So I think there at least one, but probably a couple. If I don't remember these problems on Leetcode, but in general, there are probably a couple of Leetcode problems that uses Cadane's. So definitely search on that and go over it. But yeah, but basically for now, I will go over. I won't go over it in details because I don't know. But I will just write the core because we do need to write the core, right? So basically, the idea here is that we have a current thing, we have a max answer, so maybe just max answer, I don't know, or max sum. Can we take 0 elements? I guess it doesn't matter. We'll just do negative infinity. Right, so here, then for x and nums, we do current, right? If current is less than 0, current is equal to 0. But before that, we want to do max sum is equal max of max sum current. So technically, that's a little bit. No, I think that should be okay. Yeah. And basically, the idea here is that. And this is Cadane's algorithm, right? Basically, the idea is that you take the prefix, and then as the prefix gets into negative, then you want to start over from the next phase, because that means that that prefix, there's no way to get a bigger positive answer, right? So that's generally the idea. Okay, so this is going to be the Cadane's algorithm is going to be incorrect because we didn't do the one operation, and we have to do one operation. It's not given one, because some problems it's like maybe you take one, but yeah. So then the idea here is that maybe you can have, so current, will we write it as current no operation or no op maybe? Yeah, okay, fine. And copy and paste. And technically we won't use this anymore because maximum has to have exactly 1, so this doesn't make sense really, but we'll leave it here for whatever. And then maybe we have a current 1-up, right, is equal to 0, and then basically the current 1-up is the and maybe this is actually negative infinity, because technically we should have at least one thing, right? And basically this is now we do the tick no tick, except for we're doing it in a DP kind of way or bottom up kind of way instead of top down. Maybe I should have done this top down, I don't know. But but yeah, basically here this is no tick, right? And then tick is well, 1-up we just sometimes is equal to, well, it's either the max of this plus x, or because basically we already took one operation and then we add the current number because we don't have any operations left, or you is the current no op plus x times x, right, using the square thing. And then here of course you convert it to 1-up, and if the no op is less than 0 we convert it to 0. Do we convert 1-up ever? No, I think we're okay with the, we don't have to update the 1-up because it will come from the no op anyway, so I think that part should be good. Yeah, so I think, I don't know why this takes so long. I think this is just server because we don't, this is just a for loop. Alright, a lot of technical difficulties. Alright, we have the wrong answers, but that's fine. Let's see why that is. Yeah, okay. No, I think I like the way this is structured. So why is this wrong? Okay. So 2 and then 1 and then 16, so it's 17, right? So okay. So I mean, I think the answer is let's print it out to see what is going on. Instead of me guessing really. Oh, this is a little bit awkward. I see why this, because this is at the very least this this double counts this, because this we update the current no ops, so that's just a little bit sloppy actually. Okay, so I guess that was it. Whoops. Oops. But alright, so this looks good. Let's give it a submit. Hopefully we didn't miss an edge case, and there you go. This is linear time, constant space, but yeah, but as I said, this is how you can convert, I guess, Cadane's algorithm with one operation, with exactly one operation, and that's how you kind of do it. Yeah, and I guess I did also do the space optimization thing right here explicitly, but ahead of time, I don't know. Let me know what you think. I think this is a pretty cute problem. Definitely also, to be honest, if you're trying to do dynamic programming, this is a very good like intermediate dynamic programming problem. Like maybe not the first 10 dynamic programmings you learn, but after that, especially if you learned Cadane's algorithm, I think it's a good thing to kind of like give you this idea about like playing with the dimensions and stuff like this. And adding a dimension. This I didn't do it. I didn't write out the code in a way that explicitly shows an extra dimension, but it is there. So I think that could be interesting. Anyway, I'm gonna go for a walk. I have high blood sugar. Being old, don't do it if you can help it. So yeah, I need to go over a walk after lunch. So that's all I have. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.